Yuki.
Hi, I'm Kim.
Hi, I'm Ariel.
Oh, and hi, I'm Lauren.
And we're going to explain to you the role of heat in X-ray imaging.
Ta-da!
Heat. Heat is the form of energy that is very, very important to radiologic technologists. Heat is the kinetic energy of the random motion of molecules. The faster the molecules is vibrating, the more thermal energy the substance has, and the higher the temperature will be. 99% of the kinetic energy of projectile electrons in the X-ray tube is converted to heat. Excessive heat can cause permanent damage to the X-ray tube. Examples of damages are melted anodes or ruptured tube housing. In order to prevent damages of X-ray tube, the X-ray equipment operator must be aware of the role of heat and how it transfers in the X-ray tube. Now, Lauren is going to explain about the transfer of heat in the X-ray tube.
Thanks, Yuki. Heat transfer is so important to us because excessive heat can result in shorter X-ray tube life. But proper utilization of heat transfer can help prolong the X-ray tube's life by dissipating heat effectively in daily use. Conduction, as shown here, is the transfer of heat through a material or by touching. It says, but her hands are so sweaty. And this one says, but his hands are so sweaty. It is easily observed when a hot object and a cold object are placed in contact. After a short time, heat conducted to the cooler object results in equal temperatures of the two objects. Convection, as shown here, is the mechanical transfer of hot molecules in a gas or liquid from one place to another. Thermal radiation, radiation as shown here, is the transfer of heat by the emission of infrared radiation. The reddish glow, like in the coals, emitted by hot objects is the evidence of heat transfer by radiation. So in terms of the X-ray tube, heat is conducted from an X-ray tube anode, like this one here, through the rotor, here, to the insulating oil by touch. That oil acts as the liquid that convects the heat to the tube housing, which is all on the outside. Lastly, the tube housing radiates the heat off and it eventually dissipates to cool itself. Now, Kim is going to explain the role of heat in the cathode.
Okay, thanks, Lauren. When the X-ray imaging system is first turned on, a low current passes through the filament to warm it and prepare it for a thermal jolt. Thermal meaning heat, necessary for X-ray production. So the current comes in and it goes across the wire, down into the focusing cup, and into the filaments. The filament heats up and releases a bunch of electrons called thermionic emission. Once kilovoltage is applied to the tube terminals, the electrons instantaneously accelerate towards the anode and go out the tube. And Ariel is going to explain that process to you.
Okay, thanks, Kim. Most of the kinetic energy of the projectile electrons from the cathode is converted to heat by interactions with the outer shell electrons of the target atoms in the anode. These interactions are primarily excitations rather than ionizations. And I'll show you here at the target atom what happens. So when the electron from the cathode interacts with the outer shell electrons of the target atoms, they do not transfer sufficient energy to these outer shell electrons to ionize them. The outer shell electrons are raised to an excited state, and the outer shells immediately drop back to their normal energy level with emission of infrared radiation. The constant excitation and return of the outer shell electrons are responsible for Most of the heat is generated in the anodes of the X-ray tubes. The production of heat in the anode increases with increasing energy tube current. Doubling the energy tube current doubles the heat produced. Heat production also increases directly with increasing kVp.
Heat is a form of energy that is very important to you.